in the middle of a US government shutdown, one object is still moving through the solar system quiet, steady, and impossible to ignore. And somehow, it's forcing NASA, Congress, and even the Pentagon to respond at the same time. This isn't a UFO rumor. This isn't internet hype. This is 3I Atlas. NASA has been tracking it around the clock. Even while most of its public operations are frozen, Congress is demanding new images and new data immediately. And over at Harvard, scientists are pushing for full transparency before anything slips through the cracks. Everything feels tense. Like the whole situation is balancing on a tight wire. Because whatever is happening with 3I Atlas, it's unfolding right now. In real time. While you're watching this video. But the real reason Congress stepped in wasn't the brightening. It was what happened right after. On October 29th, when 3I Atlas swung past its closest point to the sun, telescopes picked up a sharp burst of light, exactly the kind of flare you'd expect from a comet waking up under intense sunlight. Nothing unusual at first glance. Until scientists zoomed in, they started spotting tiny jets, water vapor, carbon compounds, and even faint traces of metals venting from pockets of ice that had been hiding in the dark for millions of years. All normal behavior for a comet, mostly. Because here's where things got interesting. Those jets didn't push Atlas the way the models said they should. Instead of drifting along a smooth, predictable curve, the object gave a subtle sideways nudge like a paper boat being blown by a fan, but tilting just slightly off the expected line. It wasn't dramatic. It wasn't dangerous. But it was off, just enough to make every orbit modeler sit up straight. And that tiny deviation is exactly what pushed NASA to brief Congress. The models were clear. If Atlas vented evenly, it should glide through space like a clean mathematical curve, smooth and predictable. But that's not what the data showed. Instead, scientists kept catching these tiny little shoves, barely noticeable bumps that didn't fit any of the simulations. These weren't signs of anything artificial. No one was jumping to that conclusion. But they were real anomalies, just enough to disrupt every predicted orbit path. NASA and the European Space Agency had to revise Atlas's trajectory 3, sometimes 4 times. Just to keep the tracking accurate. It wasn't fear of impact. That wasn't the concern. What worried them was simpler. And somehow more unsettling. They couldn't explain why it was moving the way it was. And just as they were trying to pin down the cause, a familiar name stepped in and shifted the entire conversation. Yes, Avi Loeb. The Harvard astrophysicist who once split the scientific world in half over Oumuamua. The moment Atlas's data started behaving strangely, he called for full transparency. He pushed NASA and ESA to release the raw images, the spectral readings, and even the orbit correction logs every detail that might reveal what forces were acting on this interstellar traveler. He didn't claim it was artificial, not once, but he said, the most Loeb line imaginable, investigate without bias. Don't ignore unexpected forces. And that alone was enough to pull Congress deeper into the situation, especially Representative Anna Paulina Luna, who demanded updated data immediately. But the reason she moved so quickly had to do with another agency no one expected. The Pentagon's AARO office released a short, almost suspiciously simple statement. 3I Atlas is fully identified and poses no security concerns. On paper, it sounded routine, just a procedural note. But the real question hit immediately: why would AARO, the office responsible for UAP investigations, comment on a comet? Their intention was clear: shut down rumors before they spiraled out of control. Prevent the internet from exploding with wild theories. But ironically, stepping in so early had the opposite effect. People who hadn't been paying attention to 3I Atlas suddenly wanted to know why the Pentagon was so eager to calm everyone down. And just as the media frenzy started to build, a global observation campaign quietly switched on behind the scenes. Across both hemispheres, NASA, ESA, and observatories from Arizona to Europe linked their instruments together, forming a worldwide network focused on one fading object. Think of it like this: dozens of cosmic flashlights pointed at something smaller than a bus, nearly 500 million kilometers away. They monitored everything, every fluctuation in brightness, every hint of an ion tail forming, every shift in the carbon-oxygen signature, every expansion of the comet as Atlas drifted into colder space. This phase was critical. Atlas was dimming quickly, within months. It would slip beyond the reach of even the most sensitive telescopes, and the very last bits of data captured as it disappears might rewrite everything we know about how matter travels between star systems. As the spectral data came in, scientists noticed something quietly extraordinary. The carbon-oxygen ratios coming off Atlas didn't match the comets. We know from the Kuiper Belt the nitrogen-bearing compounds were off as well, subtle differences, but distinct enough to signal a different origin story. Imagine scooping up a handful of snow from your backyard and comparing it to snow taken from deep inside the Arctic. The crystals aren't the same. Their structure tells you where they came from. That's exactly what Atlas looks like: snow from a place far colder than anything in our outer solar system. These chemical fingerprints point toward a distant, faint star or a planet-forming disk right on the edge of freezing, where sunlight barely reaches and ices form differently. And that matters. Because if these elemental ratios fall outside solar system norms, they plug directly into one of science's biggest questions: how water, and maybe even the seeds of life, travel between star systems. A concept at the heart of panspermia, but the answer to this mystery will only sharpen when the next generation of telescopes finally comes online. When the Rubin Observatory begins full operations, objects like 3I Atlas may stop being once-in-a-decade surprises and start appearing every single year. If that happens, Atlas isn't a cosmic unicorn. It's the prologue to a new era. An era where interstellar visitors become routine rather than mythical. And as Atlas drifts into the darkness between the stars, it leaves behind something far more important than a data archive, a quiet reminder that our solar system has never truly been alone. And if the next object shows up with the same strange signatures Atlas did, this story won't just be about science anymore. It will be a reminder of how much bigger the universe is than anything we've let ourselves imagine. Stay curious. Stay critical.